Okay, thank you. So that's the first one, guys. The y-intercept was 0, so the q was 0. So then I type the -1 and the +1 so that I can get a point on either side of the y-axis. They ask for the axis of symmetry. Can't really label that because it is the y-axis, right? So I just wrote it there. That's what A of x is. And I'm just realizing now I didn't write it for any of the others, but it's the same for all of them, right? The axis of symmetry is the y-axis, sorry, not the y-intercept, the y-axis, which is the line x equals 0. So that is the case for all of these. Any questions on that one, guys? Well, mine is. We move on to the next one. B. There you go, there's B. It had a y-intercept of -4, right? Because it was x squared minus 4. Then you could find x-intercepts for this one. If you make y equal to 0 and you solve for x, -2, and then it's a +2. Axis of symmetry, again, the line x equals 0. Y-axis. Yes. Yes. Yeah. Yeah. Guys, in a test or exam, if they just ask you to draw the graph, then we don't actually look at your calculations. So you can do it in any way. You can even do it in your head, which I won't always suggest, but some of you might be able to do that. We literally just mark your graph. Unless there's a question that says, calculate the x-intercept, like 1.1. Write down the y-intercept. Then obviously you have to write it down. 1.2, calculate the x-intercepts. Then you have to show your calculations step by step. But then they'll ask you to draw the graph and then you do draw the graph. Yes, so you just follow the instructions. No. If it doesn't say draw the graph, then don't draw the graph. Yes. No, you could still use the other method as well. Yeah. But guys, if you're using the factorizing method, if they're asking specifically find the x-intercepts, you can't go straight from this line to that line. Okay, you would have to show your working, whether it is factorizing or taking the 4 across and plus minus squared. Yes, Delilah? Have you marked any? Yes. I'll go back up to that again at the end.
-1, 2, 1, 1, 2.
Guys, in terms of marks here, you'll get a mark for your y-intercept, a mark for each x-intercept, and then you get a mark for the shape of the graph. Right, for any parabola would be worth 4 marks. Unless they've asked you calculate this, and then draw, then you'll get marks for the actual calculation, but probably only 1 or 2 marks for the actual calculation. It doesn't have to be going together. You can also use some different scales on your different axes.
It's looking like it looks like you want to like wait like being that 3, 3, 8, and you just drew over here.
Yeah, we'll make it kind of look legit. All right, there we have C. Y equals -x² plus 1.
I have mine.
Want to find that one? Questions? Okay, D negative x squared minus 1. So for D now, guys, when you are trying to find your x-intercept, you end up with x squared plus 1, which you can't factorize. It's not a difference of two squares. So this one does not have x-intercepts. So that is now another case where I think it was A, it did have an x-intercept, but it was the same as the y-intercept, right? So we typed in x values. This one doesn't have an x-intercept at all, but we need 3 points, so you choose a negative and a positive x value to type in.
Can you not determine because x is dots by looking at that? You know it's downward graph, and then you know the y is negative 1.
Sorry.
So, or vice versa, plus 1 or x up. So
Go straight into other any questions on D, guys? Down this down to Egypt now. Looking this down. The square is the negative. Which we can do an equal to these are all just real numbers. All right, those are the calculations for E, guys. E was a bit difficult to draw if you try to draw the scale, because negative 18 is very, very small, very far into the negative y-axis. So I actually, I worked with a scale of 3 units per block on my y-axis. I'll show you guys now. And then I kept my scale on this axis 1 unit per block. So it's not properly to scale, but you don't have to draw them to scale, guys. But please don't, it just shouldn't look like, don't put like a point there and have it going up. All right, don't use like the same number of blocks. I think it's actually all right, but just kind of try and make it look like it has a very low negative y value. Are there any questions on that one, guys? All fine? Okay, the last one. There you go. That point at the top is 0, 8, guys. And then we're going to look like an 8, but it's an 8 there. Again, I didn't. Oh, I did actually use the same scale on both axes, so I used one block with 2 units on both of them. But again, it doesn't matter, guys. As long as you label your points, it's fine. Yeah. You know what? It depends on who's marking.
If you were marking,
Probably. But yeah,
that's a random very one.
just practice. Yeah.
You can't, because after level X is a penalty for extra point. You have to go to the say M minus 4.
They are pretty regular, but
It's after X is a. Same with X equals, we have to say X equals.
x plus 4x minus 4 equals 0. No, you have to say x equals 4.
Yeah.
Can't be gonna keep bracket. All right, next up, hyperbolas. Actually, guys, let me quickly talk about domain and range here. We can look at this one. We spoke about domain and range when we were doing tree graphs, right? But we do need to be able to write down the domain and range of these ones as well. Domain is all the x values. We remember that, right? Now, guys, on this graph, what do we think is the smallest x value on this graph? I'm looking at x values, hey, but -4, but then isn't this a number that's smaller than -4?
So,
And this is going to keep going forever and ever, hey?
so it was just
So negative infinity is going to be the smallest x value of this one. And what about the biggest one? Positive infinity. All right. Now, guys, for that, so for the domain, you can write either. I'm literally going to say. You can either write elements of real numbers, meaning all real numbers, right? All the way from negative infinity to positive infinity. Or if you want to, you can write it like this. X is an element of round bracket negative infinity, because remember, negative infinity is not an actual number. It's not actually going to touch that number, get to that number, which is why we use a round bracket. And then positive infinity with a round bracket again. An 8. You're going to make it positive 8. Okay, so that's the domain. In fact, that will actually be the domain of all parabolas. All right, because of those arrows. Because this graph is going to continue going on in this direction. All right? Forever and ever. It's never going to end. Yes, we can. Why not? No. And then the range is all the y values, right? Yes? Yes, all that less than or equal to 8. Right? Guys, this point, the y-intercept is actually the maximum point of this graph. It's not going to do this, hey? Flip around and go back up. Okay, it's going to keep going forever, downwards forever. So this is going to have a maximum value of 8. So the range is y must be smaller than or equal to 8. Equal to 8 because there is a point there, hey? There is a point with a y value of 8. So y is smaller than or equal to 8. Guys, if we want to write this in interval notation, how would I write this? Yes, but which one must I write first? Smallest one always first. Hey, so negative infinity to 8. And now because there is actually a point with a y value of 8, you have to use a square bracket for that. Guys, for infinity and negative infinity will always be a round bracket. Okay, that won't ever change. I wanted to go back to one of the other ones that we did, one that was an upwards facing parabola. So when you guys are done with that, we can do 1A. I don't know if you have space for that on the side. So we can just go back to 1A and we're going to write the domain and range of that graph as well. Yes. Yeah, that's right. Okay, can we go back to 1A? Are you done here? Again, it kind of depends on who's walking it, how strict they be. If you have to try and get it, yeah, get it. Okay, 1A, guys. That one we're gonna write down the domain and the range of this graph quickly. So we'll just go back to 1A. Domain always X element of real numbers. And you'll never have a parabola that like stops on the one end and has an arrow on the other. Okay, we'll keep going on both sides, so X element of real. What do we think for the range now, guys? Does this graph have a maximum y value or a minimum y value? A minimum y value, right? Yes, Daniel?
I mean, why is this?
0 to infinity, yes. So you can write it like that. Y is the element of, and am I going to do a round bracket or square one for 0 now? Square. Because there is a point at 0, right? Or if you prefer, you can say y is greater than or equal to 0. Not smaller than or equal to 0. There are no y values that are smaller than 0. All of them are bigger than 0 or equal to 0. For this one. For another one. Okay, guys, next up, hyperbolas. There we go, hyperbolas. This one doesn't have another name as far as I'm aware. There's a parabola is a quadratic function. Hyperbola, I don't know, maybe one of you can find a different name. Forward, if you do some research. Hyperbola. Now, guys, the identifying factor or property characteristic of this equation is that your x is in the denominator of a fraction, right? In the other one, we haven't had that yet. With a straight line, we didn't have a fraction with an x in the denominator, right? If it was a fraction, the x was in the numerator, so like x over 2. That's the same as a half x, right? So the x would be at the top. Same for the parabola. For parabola, we have an x squared, but also not in the denominator of the fraction, okay? So as soon as you see that something over x, you need to think immediately hyperbola. I'm just going to use that app again to show you guys a few of these, so that you can see what it looks like. I'm excited. Okay, so guys, I'm going to start with the most basic one. How do I make a fraction? One. Sorry, I'm just trying to figure out how to do a fraction here. I don't know if I'm being silly. Okay, I'm gonna have to type it in differently. Okay, x.
Standard form as well. A over x plus b, and then alpha.
Yeah, but we're only doing those ones next year. So for this, yeah, it's just something over just
We always do the like y squared x or y square root x.
in the trick we think about it, yeah.
Oh, we do.
Yeah, it's not really like a section on its own, but it does. Guys, I don't know how to do it.
Should figure it out.
Will I? Looking for a slash. There isn't even a slash in here. No, I want to show you guys.
You can just show us on your at like an old.
Wait. No, I don't want to watch. Let's do. Why insulted? Why? Hello. Yes.
Wondering, can I use like 2 minutes before the end of this class?
Why?
Because I have a trial, quite exciting. I have a trial with some shop and they expect me to be there before the start of break.
Okay, that's fine. No
I'm
problem.
supposed to be 5 minutes before, but I think that's unreasonable.
Okay, sure. 2 minutes is fine. No, guys, I can't find it. Oh man, that's. That would be quite obvious, yes, and I didn't think of doing that.
Did you know?
Oh my God, that's so embarrassing. Yes. Alright, do we see this? And what's happening now? It looks like it's two paths. Hey, I'm gonna just zoom out so that you can see that these two paths don't actually ever meet. Okay, I'm still going. I'm still going. Now it looks like they're meeting, but it's just because it's so small. Now, guys, what actually happens? I must zoom in a bit as well because it kind of looks like this graph is going onto that line. Okay,
How much
and like it's going onto that line. What?
how much further can we see, guys? Can you
Yeah.
see the further left?
Further left.
Like, so it goes off the line.
Yeah, so that's what I'm trying to show you is that when we zoom way in, we can actually see that this hyperbola is not touching the x-axis, right? It's getting closer and closer to it, but it's not actually touching it. Where am I now, guys? I'm already on, oh, that's not actually that far. I'm at negative 17, and now it doesn't want to go anymore.
Yeah, they make it very big. Scroll up very far and then scroll back in.
And then it should then eventually.
You guys are getting all the technology pointers today, hey? Let's go to negative. No, I don't want to do that. That's useless. Okay, I'm at negative 224. Let's see what's happening at negative 224. It's still not actually touching the x-axis. So guys, what do we call a line that the graph goes closer and closer towards but doesn't touch? An asymptote. An asymptote, yes. Yes. But guys, we are not going to draw it to negative 224, hey? We're not going to be like that. We're just going to draw it. Let's just keep going back. Okay, so that's the same thing. Please focus, please. Thank you, Josh. The same thing happens with the y-axis as well. All right, I'm not going to go through that whole spiel again. I'm just going to have to take my word for it. But the same thing happens there. That this graph on that side and here goes infinitely close to the y-axis, but doesn't touch it. So for a hyperbola, you are always actually going to have two asymptotes. All right, one vertical asymptote, which is going to just be the, we just think, which is going to be, no, it's one graph. No, this is one graph with two. So you're always going to have a vertical asymptote and a horizontal asymptote. All right, so I'm going to write BA for the vertical one and HA for the horizontal. All right. Let's quickly do y equals 1 over, wait, let me use brackets, sorry. 1 over x, close bracket, hello? Plus 2, all right? So I've done 1 over x plus 2, guys. So 1 over x that has the same shape, but now it's plus 2. What's happening now? Is the x-axis still my horizontal asymptote? What is now my horizontal asymptote? What does it look like? What value is this graph getting infinitely closer to but not touching?
So the true value is your asymptote.
2, hey? Y equals 2. Remember, guys, if this line, I could draw a dotted line in there, that's actually what we're going to do. Yeah?
The Q is
Yes.
sorry.
That line there would be y equals 2 because it's cutting the y-axis at 2. All right. So guys, what happens with a hyperbola is that your Q value is always going to be the value, the y value of your horizontal asymptote. Right. Up until now, the Q value is in the y-intercept. Not anymore. Okay, with this one, this is going to give you your HA, your horizontal asymptote, and the equation of that asymptote is going to be y equals Q. You are going to do horizontal asymptote. I've said it about 7 times. Okay, well,
I have lost it.
yes, horizontal asymptote. You can write it out in words as well if you want, guys. Horizontal asymptote.
And he has no fear of like being in trouble. He's like, no, it's fine. No, it's
The vertical asymptote, yes, A is Y. A is Y, MPT.
fine.
MPTOTE. like this. It's a silent P, guys. But if you try really hard, you can say it. Yes, there we go. All right, now guys, we are going to draw that line in using a dotted line unless it is the y-axis. Sorry, the x-axis, not the y. Unless it is the x-axis, thank you. Then we don't have to draw it in. Okay, because it's already there as the axis. Now for in grade 10, you are only ever going to have one specific vertical asymptote, and that's going to be the y. All right, in grade 11, we're going to move it. So you can have like x equals -1, x equals 2, whatever. The vertical asymptote will move in grade 11, but in grade 10, the vertical asymptote is always going to be, so VA, right, vertical asymptote is going to be the y-axis. And what is the equation of the y-axis again? X equals. So we're not actually going to have to draw that in because it is just the y-axis. It is already drawn in. Now guys, if the y-axis is an asymptote, are we going to have a y-intercept? Remember, what is an asymptote? It's a line that the graph goes closer towards but doesn't touch. So since the y-axis is an asymptote, we can't have a point on that line, on that y-axis. So that means that we are not going to have a y-intercept. So no y-intercept. We could still have an x-intercept though. What are we going to do to find the x-intercept? Make y equal to 0. Which is going to give you an equation that looks like this. Remember, A and Q are going to be numbers, all right? So we'll just have to be able to solve for x from there. We will do an example just now. Now that's the axes of symmetry, and I'm saying axes of symmetry because there are two. For hyperbola, a parabola only had one, right? But for hyperbola, let me quickly go back to this picture. I wonder, can I remove the blue one? Oh, I can. Okay. Guys, for this graph, I think we all can imagine that if I were to draw a straight line there, that would be an axis of symmetry, right? Yes, because the graph is symmetrical about that line. So if I fold this top part over, it should fit perfectly onto that bottom part. But now, what about a line that goes like this? Right? It should be like a 45-degree angle there, you can imagine that. Right? That is also going to be an axis of symmetry because if I now fold this part over, which consists of those two halves, essentially, of the two parts of my graph, over this line, the two parts should fit perfectly on top of it. Now, guys, the way of calculating your axis of symmetry, I'm just going to write it over here. Actually, very easy. It's going to be y equals x plus q. That is going to be the one. Now, guys, if it's just y equals x plus q, what is my m value? This is a straight line, right? Straight line, x plus c. What is my m value? Jonathan? Oh, no. You're not answering my question. I want someone to answer my question, please. What is my m value here? Yes? 1, right? Positive 1. So this is going to be the one that looks like that. Okay, that is going to be the axis of symmetry with a positive gradient. You are going to have another one though, the one with the negative gradient, right? The first one that I showed you guys. And very easy, that is just going to be negative x plus q. The same q value from the equation of your graph. It's there, so you just use it. Don't worry about it. It will always be x plus q and negative x plus q. It's not going to have a different gradient, right? It always has to be at that 45-degree angle, right? Which is why it has a gradient of positive 1 and a gradient of negative 1. Yes, Jonathan, what is your question? Okay, we are going to draw one now, guys. There is an extra step that we are going to do, but I don't want to say that, because you're going to get confused, I think. So just let's do an example together. So you can just write example. One other thing that I do want to add to this is these two. Wow, that's not good. But I'm not quite sure what's going on. These two axes of symmetry, guys, you only draw them in if they state in the question that you have to. Okay, so for the axes of symmetry, only and you draw when asked. Exit, you're always going to have to plot that. Your asymptotes, you're always going to have to put those in. But the axes of symmetry, guys, the question, you only draw that if it actually stays in the question that you have. So for this example, why don't you freezing that one? I don't need example. We are going to draw one of these together and then you're going to do some practice on your own. So draw the graph. Y equals, I really like the one that they have in the book. The different one. So it just has big value of 9. I want to do 9. Go up to 9. Sorry, I'm just seeing if I can find a different equation, otherwise I'm going to have to make one up. Negative, no, that's too basic. Negative 2 over x plus 4. Okay, I didn't say, but the a value also basically just changes the shape of it. Just how steep one or not steep it is, but it's fine. Doesn't matter. Yes.
They were always going to only work up.
Yes, well, the x asymptote is the y. Yes. But you see, all we're going to do is we're going to calculate the points and plot them whenever we know that it's possible. All right, guys, for this, do we recognize that this is the equation of a hyperbola? I see that it's something over x, right? So that means that it's a hyperbola. 4, that is my q value. That means that my horizontal asymptote is going to be at y equals 4. So you're going to draw that in as a dotted line. What about the vertical asymptote, guys? The vertical asymptote is the y-axis, right? Which is the line x equals 0. We're going to have a y-intercept if the y-axis is an asymptote? No. But if you try and calculate the y-intercept, say you forget that, right? I'll just show you what's going to happen. What do we do to find the y-intercept? We would make x equal to 0, right? So you would say, okay, I'm going to make x equal to 0. So in my equation, I have y equals negative 2 over x, right? Over 0. Oh dear, can I do that? No, hey? That is undefined. You don't have to do this. I'm just saying, if you forget that you're not going to have a y-intercept and you try and calculate it, then this is what would happen. Alright, if you can't calculate the y-intercept, then there is no y.
Okay. In order to move where the graph is, like left to right,
Yeah.
would you measure a number of inverse like plus 1
Alright, for the x-intercept, we are going to make y equal to 0 and then solve. In our equation, so we're going to have negative 2 over x plus 4 equal to 0. Okay, you're not going to be able to solve this in just one step unless you kind of do it by intention. So I'm going to move the plus 4 over, right? And I have negative 2 over x equal to negative 4. What can I have with those two minuses? What's a negative divided by negative? Positive, hey? So the minuses then basically cancel each other out. What's the I'll do about x? I'm going to have to multiply out by x, right? So I'm going to have 2 equal to 4 times x. On this side, I'm dividing by x. The opposite of dividing by x is multiplying by x. All right, now we must divide by 4. What's 2 over 4? Okay, so my x-intercept is going to be the point of 0. Now guys, at the moment, how many points do I have? 1. How many parts to this graph is there? The 2, hey, we saw on when I showed you the graph, there are actually 2 parts to this graph. So guys, when you are doing your calculations, you will only ever find 1 point, right? The x-intercept, because there is no y-intercept. So now we're going to have to figure out which part of the graph is this point on, and then we need to find a point on the other part of the graph. 1 point is enough, yes, 1 point is enough. Okay, if you can't do that visually because it is the first one, let's quickly draw this. All right, let's plot what we have. Let's draw in our asymptotes. Let's do that. So guys, draw your set of axes quickly. You are going to want to make your y-axis quite long at the top because look at where your asymptote is at y equals 4. Okay, so it has to go up quite high. So maybe make it go up to like 7. All right, because we're going to have to draw something above this asymptote. Around there. What did I do now? 1, 2, 3, 4, 5, 6, 7. Yeah. Maybe make it go up from this one. No, but 1.2 on a clock. Well, the asymptote line back or what? You can do 7 down if you want. We'll see now what happens. At y equals 4, I'm going to draw my dotted line. Okay, at first, guys, I can't make mine dotted. Remember, I have to do that whole erasing, guys. So 1, 2, 3, 4. I'm going to do it in blue. And I'm just going to draw a line going all the way across. Put your arrows on and write y equals 4. Remember when we drew asymptotes for tan graphs, we wrote above those asymptotes x equals 90, x equals 270. You have to please label your asymptote, guys. I'm just quickly making this a dotted line. There we go. And now we can plot that 1 point that we have. What was it again? Half 0, okay? So at x equals a half and 0, you can plot that point. Guys, it doesn't have to be to scale, so I'm thinking maybe I'll just move mine, I'll say that that's a half. Right? Adding that. I don't like drawing it when it's too close to the asymptote because then it makes it a bit more difficult to draw. I'm going to label that point just now and I've actually drawn my graph in. Now guys, what is this part of the graph going to look like? It's supposed to go towards that asymptote and towards this one, hey? So you can just kind of freehand that, make it look like a curve. It doesn't have to go up close to the asymptote. Just make it obvious to the marker that it is going towards the asymptote. All right. At the bottom, same thing. This one is going to be a bit more difficult. Actually, wait. Let me adjust mine a bit. Like a straight line.
Another straight. Or like slightly straight.
I think I know what you mean. It's not meant to be like super straight. Only at very high or very low times. Oh, I thought it was frozen the whole time. You guys could see that. Okay, half and 0. Guys, that's not the full hyperbola, unfortunately. We're supposed to have another part to this graph. Where do you think that other part is going to be? Above this one? On this side. Over there, hey? So the two, remember, are always like diagonally opposite each other. So guys, I need a point on this graph. I can't just sort of do this, all right? I need to have a point there. I need a point on that side. So we're going to have to choose an x value. That will definitely give us a point in this section. What type of x value? We're going to have to do a negative x value, hey? Negative, you can now decide whatever negative value you want. But if you want it to be like kind of symmetrical, you can do negative a half. You can do -1, you can do -2, whatever. Guys, it is sometimes quite useful to look at what will like give you a whole number in your equation. It's optional, but just look at this. So if I do like -2 there, what am I going to get for my y then? What's -2 over -2? 1 plus 4 is then going to give me 5. Hey? Or you can do -1/2, but then you're actually going to get quite a big number. It's like -1. Yes, which is going to give you -2 over -1 is 2 plus 4 is 6.
So do you have to?
Now it's just,
And then we get to. What do you want?
it can't be 1, it has to be -1.
Um,
So that's negative, because we have to have a negative x value to get a point on that section. So guys, the important thing here, I'm going to write a little note at the bottom now. When we are subbing in an x value, I can't sub in +1, and then I'm going to get another point on this side. I can't sub in 2, because x equals 2 is over here, right? Then I'm going to get another point on this part of the graph. I have to sub in a negative x value, because that is the only way for me to get a point on this part of the graph. So I'm going to make a note here, guys. My x-intercept, do we all agree that this is a positive x value? Positive a half, right? This is positive x value. So because I have a positive x value, that is a positive point, right? The point of the positive x value. So then I have to sub in a negative x value to get a point on the other part of that graph. So therefore, choose a negative x value to get a point on the other part of the graph. Sorry, it's a bit long-winded. Guys, if your x-intercept was negative, you will have to choose a positive x value to get a point on the other one, right? So your x-intercept actually is telling you what type of x value you're going to sub in. If your x-intercept is positive, you need to sub in a negative x value. If your x-intercept is negative, you need to sub in a positive x value. Okay, so now I'm going to do, I'm actually not sure which value I want to sub in. What should we do, guys? Tell me. -2, okay. Again, you can choose whatever, all right? As long as it's negative, that's the important thing.
the hyper-
It doesn't have to be symmetrical. If you want to make it symmetrical. the graph will automatically be regardless of what point you plot on.
Yeah.
So you are just plotting one point on the graph, but they are an infinite number of points on the graph. But Jonathan, if it makes you feel better, sub in negative a half. So our x-intercept was a half, so sub in negative a half. What? Yes. Okay, what's negative 2 divided by negative 2? 1 plus 4 is 5. So that gives us the point negative 2, 5. Which if you then go to your negative 2, oh, but now I said that that's negative a half, so my negative 2 is actually going to be there. That seems odd. And what is it? 5. Hey, 1, 2, 3, 4, 5. Fine. Even if it looks a bit odd, I'm just going to label it, and then you must take my word for it. All right, and now we are drawing it so that it goes towards the 2 asymptotes. Could be a bit more around there at that point. Let's see if I can fix that. I'm sure that's much better. Anyway, it's all right. Negative 2 and 5. Or another value, guys. If you subbed in, actually, that's even, yes, that is fine. If you subbed in negative a half, you would have a point at negative a half over there, right? If you subbed in negative 1, subbed in negative 1.5, even if you want to, it really is up to you which x value you want to sub in. But guys, if you've chosen an x value to sub in and it gives you an awful value, an awful y value, say for example, I drew my y-axis to go up to 8. Now, if I got 12 as a y value, I'm just going to choose a different x value, right? If I say that again, if you chose a specific x value and you subbed it in, and you're getting a y value that's maybe off of your y-axis, or it's like a decimal thing, or it's just not a nice value, just choose a different x value, okay, and sub it in. You can choose any negative x value, as long as it's negative, that's important. Okay. What I want us to do now is to actually draw the axis of symmetry, all right, just so that you get an idea of that. So let's quickly go back to the equation of the graph. This was the equation, the axis of symmetry. I'm going to have to go this down. Remember, the one is y equals x plus q. I'm just writing the equation again. Guys, this doesn't change. It's always x plus whatever your q value is. So it's going to be x plus 4. Y equals x plus 4. Maybe I should write that underneath. Y equals, you can keep it on the side, it's fine. We'll just rewrite it at the bottom. Y equals x plus 4. Guys, that's a straight line. Yes? With the y-intercept up? Y-intercept up? 4. We know how to draw straight lines, right? We just did at the beginning of this section. That is a straight line. We're going to have a y-intercept of 4. Is that enough to draw the graph? What else do I need? The x-intercept, okay? To get the x-intercept, you have to make y equal to 0. So guys, this is an easy one to do. X plus 4 equal to 0. What is x going to be? If it's x plus 4 equals 0, x is going to be negative 4, hey? You can write that working out if it makes you feel more secure. That's perfectly fine. But you can also just do it in your head. It's an easy one to do. X plus 4 equals 0. You take that 4 over. Yeah, it's actually like that. Let's quickly just do for the other one as well. Let's do the calculations. I'll show you a trick to draw it. All right, so guys, this very simple is going to be negative x plus 4. So the q value is 4. All right. This one again is going to have a y-intercept of what? What is the c value here? 4 again, hey? So guys, the two axes of symmetry always have the same y. All right, 4. Which is also the point where you have your asymptote, right? That's y equals 4. We'll look at that now. And then for the x-intercept here, again, you must make y equal to 0. So you're going to have negative x plus 4 equal to 0. Then you can just move the x across, hey? You have x equals 4. So for this one, the x-intercept is going to be 4 and 0. Not for the hyperbola, but these are straight lines. These are the axes of symmetry of the hyperbola. Now guys, if you use the same scale as me, sorry, you won't be able to plot these x-intercepts, right? Because negative 4 is off of my axis and 4 as well. So what can we use instead? If we can't plot that x-intercept, what can we do? What is the other method for drawing a straight line? Gradient, hey? What is the gradient of this graph? 1. So I can just use that from my y-intercept. I can just do count 1 up and 1 to the right. It's not ideal, it's just because I didn't think ahead when I did my axis. Yes. Sure, is that hungry? Wow. And for this one, the gradient is negative 1 over 1. So we're going to go 1 down and 1 to the right. Remember, you must take your gradient and write it as a fraction. So 1 is the same as 1 over 1. Yeah, I just always write it. Negative 1 is the gradient.
That's the point.
No, it's not a point. The gradient. We're just going to count according to that. Okay, guys, so let's quickly go back up to the graph. Let's plot our y-intercept, right? Y-intercept. Okay, thank you. Now, do you guys see what I'm saying? My negative 4 is going to be somewhere over there. Right? If you drew your axis long enough, then just plot negative 4 and draw and connect it. Perfect. I can't do that because I didn't think ahead. So now remember the gradient was 1 over. I've checked with myself who's using a different gradient or different scale. So 1 up and then 1 to the right. Okay, you must just follow your scale that you use. So for me, it was 1 on the y-axis and 1 across. We'll do another one tomorrow where the scale is actually done correctly. And now you must join them, guys. Doesn't look like it's to scale anyway, whatever. I'm feeling myself, but it's fine. I'll get over it. And guys, it's also often we draw these as dotted lines, but it doesn't really matter. And guys, the nice thing also is you don't have to label any points on the axis of symmetry. You can just label the actual axis of symmetry. Right, so just write the equation of it there. I'm not sure why mine is so far off. I think it is because I used a different scale on the two axes. We'll fix it tomorrow. And then same thing on the other one, the negative one, also y-intercept of 4, and then we have to go 1 down and 1 to the right. So you'll have a point over there. How am I going to do this one? I'm going to have to turn my device here. Okay. And then you disconnect them, guys. Sorry about this. We will do one tomorrow that looks better. But I think you get the idea, hey? Do you not get the idea? Do you get the idea? Yes or no? Yes, okay. That's the important thing. Yeah. Not perfect, but it's because it's human drawn. It was on a Okay, so guys, even though the gradient doesn't look, it looks a bit odd there, but you could kind of visualize this happening, hey? And you can kind of just envision that happening. Did I say visualize?
Visual.
I said visualize. I said visualize. You know what I mean, guys? That's what I'm saying. Okay, guys. Tomorrow is 8. We actually have to go to your tomorrow, right? 8 o'clock, I think. Yeah, I was dropped there, but you guys worked on it in class, so I think you must have probably finished. Just double check on